All right, so before I do the next example, we need to look at these limit laws, okay? And these limit laws apply as long as the limit as x approaches a of f of x and the limit of as x approaches a of g of x both exist. All right, they both have to exist. All right, and so if we have a sum and we're trying to take the limit, so we have the sum of f of x plus g of x here. This first one, it's the sum law. We're trying to take the limit of f of x plus g of x, and all we need to do then is just take the sum of the limits, okay? And so a lot of these are pretty straightforward, all right? The same thing for a difference. If we have a difference, f of x minus g of x, and we're trying to take the limit as x approaches a, we can just take the difference of the limits, okay? Constant multiple, if we have a constant multiple of a function and we're trying to take the limit as x approaches a, we can take the constant multiple of the limit. All right, so I think these are pretty straightforward. If we have a product, right, the limit of a product is the product of the limits. If we have a quotient, right, the limit of the quotient is the quotient of the limits. Of course, the denominator can't be 0, though. That's one little caveat there. So you have to be careful if the limit as x approaches a of that denominator is 0, right? Can't divide by 0. Okay, if we have a power, right? If we take the limit of a power, the power of a function, we can take the power of the limit, all right? And then we have the root. Now remember, this is a root because like the square root is a 1/2 power, right? So just remember that, square root of x is equal to x to the 1/2, right? The cube root of x is equal to x to the 1/3. So that's why we have this 1 over n. And so now the trouble is that when n is even, right? So like this, we can't take the square root of a negative number, right? Same way with a 1/4, a 1/4 root, or 1/6 root. In any even root, we can't take the root of the negative. Now, when it's odd, it doesn't matter, right? I can take -8 and take the cube root of that, right? And that's a -2. So that's not a problem. It's just when those roots are even, where we have a little bit of an issue. But effectively, the limit of a root is the root of the limit, again, provided that the we have a little issue when it's an even power. Okay, so all right, let's go on to the next example and show how these limit laws apply. All right, so these are going to seem a little putsy, right? But we're going to go through this the long way and show you how those limit laws apply. Okay, so in this first one, we have the limit as x approaches 5 of this whole thing. Right, we have the limit of this whole thing in parentheses. All right, so we got a parentheses around the limit. And then we have parentheses within that as well. So we have to be careful of the order of operations, right? Because we have another set of parentheses here. Okay, so we have this sum, and then we're taking that whole sum and multiplying times g of x. All right, so we had to take this one step at a time, at least initially here. We're just going to take it one step at a time. All right, so I'm going to say that I'm going to use the limit laws because it says here that the limit as x approaches 5 of f of x is 9. The limit as x approaches 5 of g of x is 1/3, and then the limit as x approaches 5 of h of x is -6. All right, so all those limits exist, so I can apply the limit laws. Okay, if those limits don't exist, then we have to be careful. All right, so those limits all exist, so I'm just going to apply the limit laws. Now, the first thing I see is the product, right? So I'm going to break this apart and do the limit as x approaches 5 of the f of x plus h of x. okay? Because there's a product of that thing in parentheses times g of x, all right? And then I'm going to multiply that times the limit as x approaches 5 of g of x, okay? All right, now I know what the limit as x approaches 5 of g of x is, but I'm going to go ahead and let's take care of this sum. So I have the limit of a sum. It's the sum of the limits. So again, I've got parentheses here. So I'm going to move the limit inside the parentheses. So I have the limit as x approaches 5 of f of x plus the limit as x approaches 5, of h of x. And then all of that times the limit as x approaches 5 of g of x. Okay. All right, so now I know what these limits are, right? I can replace these limits with their values. And so this first limit as x approaches 5, f of x is 9. And then this limit as x approaches 5, h of x approaches a negative 6. All right, now can't forget those parentheses. And then the limit as x approaches 5 of g of x is 1/3. So we end up with 3 times a third, right? 9 minus 6 is 3. 3 times a third is just going to be 1. So our limit here is 1. All right, I know it's a little slow and putsy, but bear with me here. All right, we got one more. Now, again, we're just going to apply those limit laws one step at a time. So, actually, I think I'm going to put it here. Okay, so first thing, I have a difference. So I'm going to take care of that difference. So I'm going to say the limit as x approaches 5 of f of x minus the limit as x approaches 5 of this whole thing, h of x over 6 times g of x. Okay. All right, so I got the first thing. It's, I know what the limit as x approaches 5 of f of x is, but I need to take care of the quotient. All right, so, all right, let's see. I think I have room over here. Let's rewrite this. We still have the limit as x approaches 5 of f of x, and now we're going to take the limit of the quotient. So it's subtraction, right? So I'm going to move the limit inside. The limit, limit as x approaches 5 of h of x over the limit as x approaches 5 of 6 times g of x. Running out of room here. Just enough room. Okay. All right. Now we're getting there, right? So now I just need to take care of that 6. The denominator here, I've got 6 times g of x. So, all right, bear with me. We're going to rewrite this. I like to rewrite each step by step. Each thing here is equal to the thing before it. All right. So I can leave this as it is. I have the limit as x approaches 5 of h of x. And then I'm going to have all of that over 6 times the limit as x approaches 5 of g of x. All right. Now everything is all taken care of. I have the limit of f of x, the limit of h of x, and the limit of g of x. Okay. So now we're just going to do substitute those values in. Okay, so this first limit is 9, and then the limit as x approaches 5 of h of x is a negative 6. Oops. And then in the denominator, we're going to have 6 times a third, right? Because the limit as x approaches 5 of g of x is a third. All right, so now it's just a matter of simplifying that. We get 9. Now I'm just going to move the minus inside and make this a plus. Okay, so then I have, and I can cancel the 6, right? And 1 over a third is 3. Okay, so I end up with 9 plus 3, which is equal. I meant to write an equal sign, 12. Okay, so that's our final answer. Our final answer, I'll put a box around it since there's so much to look at here. Final answer here is 12. All right, So we've used limit laws now. Now the key thing here is that those limits have to exist in order to apply those limit laws. And in the next example, I'll show you one where the limits don't exist and what we can do there. All right, I'll meet you in the next video.